Okay, so algebra students, we are now down to our very last section in chapter 2, and that's working with those absolute value inequalities. So we are now looking at absolute value, which are these lines right here. And absolute value talks about a number's distance from 0. So this inequality, absolute value of x is less than 5, describes all numbers whose distance is from 0 is less than 5 units. So if this is my 0, I'm looking at 1, 2, 3, 4, 5. So I want anything that's less than 5 units away. So this number is less than 5, this one, this one, this one. Now this one is not less than 5. So anything up to 5, all of that is less than 5 units away. But we also have the other side of the number line. And because it's distance, we're not really looking at the negative anymore. We're just looking at how far away it is. So negative 1 is only 1 away from 0. Negative 2 is only 2 away from 0. And so all of this has a distance less than 5 units away from 0. And so when we're looking at this, we've really created this compound inequality of where we have x is less than 5 and x has to be greater than negative 5. And so what we see is that from here, we get the original inequality x is less than 5, which matches right here. But we also get the flipped. We flip this and change the sign. And so now we're starting to see where that starts happening. So with inequalities, we have the original, and then we flip and change the sign on the second inequality. So let's look at our first problem. We have absolute value of x plus 4 is less than or equal to 2. So when I write it out, I have my original x plus 4 is less than or equal to 2. And I have x plus 4, and then I flip greater than or equal to negative 2. And we're going to go ahead and solve these. Then I'll solve this one. And then keep in mind, because this is a negative, we now end up with a different number. And so when I graph, I'm looking at the numbers negative 6 and negative 2. There are closed dots because of the lines underneath. And I want x is greater than negative 6, but less than negative 2. And so we're getting that compound inequality from here. Okay, so for our next one, we're going to start off with our original 2x minus 1 is less than 5. And for the second one, we flip it, greater than, and then we change the sign. And we solve these two inequalities. So now I have x is less than 3. And then over here, I'm going to add 1. And then keep in mind, because this is now a negative 5, we have a different value here. We now have that negative 4. We divide by the 2. And we have x is greater than negative 2. And remember, this is an and problem because these are going to come together. So when I look at my number line, I'm going to have the negative 2. And then I'm going to have 3. And these are open dots. So I want it to be x is less than 3, so open dot on the 3, and then it's going to go to the lower numbers. X is greater than negative 2, so open dot on the negative 2, and goes towards the bigger numbers. So they are now joined together. Okay, now we're going to look at a slightly different inequality. Now we have the absolute value of x is greater than 5. So now when we're looking at our number line, we've got our 0, 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. So we want all numbers that are greater distance than 5 away from 0. So 1 is not bigger than 5, but 6 is. So I want anything 5 and bigger. So that would be that on this side. But on the other side, that also occurs. So I've got my open circle on the -5. Now -4 is closer than 5 units away. So I have to go then to the -6. And so everything from here. So now we start seeing that with the greater than symbol, or the greater than or equal to, these become our OR problems, because our arrows are going out and away from the center. We want a bigger distance away. And so both of those arrows are going out, and these are now OR problems. So setup is really the same. We have x is greater than 5 on this side, but on this side we have x is less than or equal to -5. So with those negatives, we're still seeing the flip and change sign. That flip and change sign right there. So that doesn't change. It's the and or that changes, but depending on what our symbol is. So greater than or equal to are going to be OR problems with absolute value. Less than or equal to are going to be AND problems. So we're going to go ahead and start off here. We have our x minus 8. We're going to have our original greater than 2. And then because this is greater, it's going to be OR. And then for my second one, x minus 8, I flip and change the sign. And so now we go ahead and solve. So x is greater than 10, or, and I add 8 to both sides, x is less than 6. So on our number line, we're going to have our 6, we're going to have our 10, and because x is greater than 10, open dot on the 10, go towards the bigger numbers. X is less than 6, open dot on the 6, goes towards the lower numbers. So again, we're seeing that OR because they are going out. So on our next one, we're going to go ahead and separate out. Original 2x plus 3 greater than or equal to 7. And then we have the OR because of the greater than. And for the second one, I flip to less than or equal to, and then we have -7. We solve each one. Divide by 2. And then I solve the next one. Now keep in mind, because of that -7, I'm going to end up with a different number over here. -7, -3 becomes -10. And this is an OR. So we've got our -5. We've got our 2. These are closed dots. So I've got x is greater than or equal to 2, so closed dot on the 2, going towards bigger numbers because of greater than. X is less than or equal to -5, closed dot because of the equal to. Less than means it goes to the left. And again, our OR problem. Okay, just as when we were solving absolute value equations, we still have to keep in mind that we have to get the absolute value by itself. So when we're looking at these problems, we're always looking at, is this by itself on its own side? And if it's not, it is our responsibility to move that other stuff away and then separate. So here I would -12 on both sides. Again, not separating yet. Then I have my absolute value times 4. Then I have to divide by the 4. And now that I have the absolute value all by itself, now I can do that separation. So I start with my original, x is less than 9. And then I have, because it's less than, it's an AND problem. And then I flip and change the sign. And this is my answer. This is my solution. And then I could graph it if I want to, but we've practiced graphing that enough. Okay, so let's look at our next one. Again, absolute value is not by itself, so I start by adding 9 to both sides. Now I have 3 absolute value x minus 2 less than or equal to 15. I divide by 3. So now I have absolute value x minus 2 is less than or equal to 5. Now that I have the absolute value by itself, now I can split it up. So I'm going to have the original x minus 2 is less than or equal to 5. And I have the other one. And I know it's an and because it's a less than. So this is going to be x minus 2. I flip and I change the sign. So I can solve each equation or inequality. So I have x is less than or equal to 7. And I add 2 to both sides. X is greater than or equal to negative 3. And so this is my solution. And you would find that if we were to graph this, they would be 2 dots that would then come together. This one would be 2 dots that would then come together. Okay, so on our next one, again, absolute value is not by itself. So I get rid of the 5. Still, I don't have absolute value by itself. It's still being times by 7. I divide by 7. So now I have absolute value of x is greater than or equal to 3. Now I have the absolute value by itself, I can separate. So I have my original, x is greater than or equal to 3. And because that's a greater than, this is an or problem. And then for the second one, I flip the symbol and change the sign. And there's our solution. Okay, for our last one, again, absolute value is not by itself. So I start by moving that plus 7. So I'm going to minus 7 on both sides. So now I have 6 and my absolute value is greater than 12. I divide by 6. So now I have that absolute value 2x minus 3 is greater than 2. Now the absolute value is by itself, so now I can split it up. Because it's a greater than, it's going to be an or. The first one's going to look exactly like it, just without the absolute value. So 2x minus 3 is greater than 2. The second one, 2x minus 3, I flip and change the sign. So from here, I'm just now solving. Add 3 to both sides. Now I have 2x is greater than 5. I divide by 2. So x is greater than 5 halves. Or I could change it to 2.5, that's fine. Or, and then I've got the other one. I add 3 to both sides. So now I have 2x is less than 1. Divide by 2. X is less than 1 half. So again, our solution, this one would look like 2 dots, arrows going out because of the or. This one up here would be 2 closed dots, arrows going out because of the or. So just another reminder to you if you need it, greater than or equal to are going to be or problems, less than or equal to are and problems. Ors will always open out. Okay, this is starting to look really bad. And our and ones will always open in. And so that's just the main idea behind our absolute value. Other than that, it's the first one's the original. The second one, we flip the symbol, change the sign. And there you go. Okay, last sort of thing that we want to talk about is that whole idea of no solution, all real solutions, and how that works with our absolute value equations. So remember that with absolute value, if we end up with less than or equal to a negative number, there is going to be no solution. Because there's no way our absolute value could be negative. So if it's saying that our absolute value has to be less than negative 2, there's no way, because there's no way that that can be smaller than the negative number. Now, if we end up with something like absolute value of x is greater than negative 2, now all of the possible numbers we put in there will be bigger, because all absolute value is going to be positive, and all positive numbers are bigger than that. And so this is all real numbers. I'm going to use the hashtag symbol for numbers because we used that before it became a hashtag. So in our sample problems, that's what we're looking at. The first thing I do is I get the absolute value by itself. So I add 9 to both sides. And I have absolute value of x is greater than or equal to -2. Well, because it's a greater than, that means it's going to be all real numbers because they're always positive, and positive numbers are always bigger than negative numbers. So all real numbers. And for those people, Lincoln, we've got our double R symbol for all real numbers. Okay, for our next one, we get rid of the -4 by dividing on both sides, and we get absolute value x minus 3 is greater than or equal to -2. And now we're looking at that, well, all values, oh, I made a mistake, hold on. I divided by a negative number and I should have flipped my symbol. Now that changes things, so we've got to remember about the dividing by those negative numbers and flipping that symbol. So that should have flipped around. Now it's flipped around. And now, can our absolute values ever be smaller than a negative number? Well, no, that's not possible, so this is no solution. No solution can also be written as a symbol with a 0 and a line through it. It's different than the number 0. It means that 0 is actually an answer, 0 is actually a number, but the 0 with the line through it is known as the no solution or the null set, where there's nothing in there. Okay, so that's it for 2.7a, and then we'll talk about some story problems on 2.7b.